Well, for the first questions, we know that this function is a probability mass function. Thus, the countive sum of this function should equals 1 according to the definition, so that we can arrive at this equation, and we can think lambda multiply t as a whole, so that we can take derivative of lambda t at both sides of this equation, so that we can get this equation, and we put e power lambda t to the left hand side, and we can know that this function here is equals the mean of xt, so that we know that the mean of xt equals lambda t. Well, to deal with the second question, we should consider a more common situations first, and we think 4 points are on a line A, B, C, D, and in the first situation, A, B, C, D have are no overlapped, so that this TB minus TA, TD minus TC are independent, so that the autocorrelation of X equals the multiple of these two means, so that we can have the autocorrelation equals this part. And in the second situation, we assume that A is is less than C, C is less than B, B is less than D, so that in this situation they are overlapped. In order to calculate the mean of this part, we should transfer them into the non-overlapped one. So we transfer them into the independent, and we can know that the mean of this part equals the product of the non-overlapped part, so that we transfer xb minus xa into xb minus xc plus xc minus xa, and we transfer td minus tc into td minus tb plus tb minus tc, so that this part can transfer into this part, and we see then tb minus tc, td minus tb are independent, as well as tc minus ta, td minus tb, and tb minus tc, and tc minus ta, so that we can transfer this equation into this one. And after several calculation, we can transfer this part into this one, and we know, and for the mean of xt minus xtc square, in the first problem, we know that the mean of xt equals lambda t, so that we can get this equation. And here we use the same method. We take lambda t as a whole, and we take a derivative at both sides of the equation, so that we can get this, and we can see that this part is equal to the mean of xt squared, so that we can know that the mean of xtb minus xtc square equals this part, and we take this part to replace into the former equation so that we can get the mean of this part equals this one. And for the third situation is that a minus a is less than c, less than d, and less than b, so that this area are overlapped. So we should also transfer it into the non-overlapped one, and in order to make them independent to get the result, so that we transfer TB minus TA into TB minus TD plus TD minus TC plus TC minus TB, so as this equation. So that because they are not overlapped, thus we got the mean of this part equals this one, and here is also the mean of TD minus TC square, so that we, according to this equation, we can know that this part is equal to this part, so that the whole part of this is equal to this one after several steps of calculations. So that here we can conclude that if TA equals TC equals 0, and we assume TB equals T1, TD equals T2, and for the second situation, we can have that the mean of this part equals the mean of xt1 multiply xt2, which is the auto correlation, and equals lambda square multiply T1 multiply T2 plus lambda T1. In this part, T1 is the smaller one in T1 and T2, and if we assume that TA equals TC equals 0, TB equals T1, TD equals T2, which is the same as this situation, so that we can have this part equals the mean of xt1 multiply xt2, which is the autocorrelation of x, equals lambda square multiply T1 multiply T2 plus lambda multiply T2. In this part, T2 is the T2 which is equal to TD, the smaller part, so that we can have, in conclusion, we can have the autocorrelation of x equals lambda square multiply T1 multiply T2 plus lambda multiply the smaller one of T1 and T2.